Okay, it looks like we just lost one or two people as I pressed the record button there. There we go. Okay. So this call is being recorded, and we'll post it on YouTube and link it from the minutes and in the Slack and on the Google group once that's sorted out tomorrow. So today we're going to kick it off like we're going to try to each month with a kind of show and tell, and that's me today. So what I've got to show you first thing in this call is a simple tool, which is really kind of a bit of a proof of concept to scan Singularity image format containers with something called the Claire Container Vulnerability Scanner. So before we go to the actual little kind of proof of concept tool I've got, I'll show you over here the GitHub page for Claire. So Claire is it's a tool. What it does is it inspects container images, and it works out what packages are installed in the image. It understands packages, package managers for different distributions, and it can recognize things in an image and cross-reference them to a database of vulnerabilities. So it knows when certain CVEs were introduced, in what version they were introduced, in what version they were fixed, if a distribution sort of backported a fix to a package, and it can inspect a container to do that. It came out of Koros, which was acquired by Red Hat, so it's now part of the Key project under Red Hat, which is their OCI registry equivalent of Docker Hub. There's another page on the Red Hat site here if you want to learn a little bit more about Claire, and I'll paste these links into the chat and the meeting minutes after this section. So the kind of tool I want to show you today is at this location here. So it's on GitHub, and it's called Claire Singularity. And this was my attempt in a previous life to do a proof of concept for scanning Singularity images with Claire. This is when I wasn't actually with Sylabs. I was working at UT Southwestern Medical Center in Dallas. We use Singularity containers a lot, and the information security people were interested in us as an HPC group exploring ways of looking at any vulnerabilities which these containers had in them, and so on. And yeah, Vanessa's just dropped in the chat that she has made a similar kind of tool. There's a repository at Singularity Hub S-Tools, which does something very similar. It's almost the same approach. It's just very slightly different how it's calling things and so on. So feel free to kind of interrupt me, shout out if you want me to kind of try and explain anything a bit more as I go through this, but there are some documentation kind of notes here, and it tells you kind of what the tool is doing, what you need in order to run it, and how to go about running it and installing it. It's a Python package, so the installation is a fairly straightforward setup py install. If you have a machine with a new enough version of Python on it. And then the only other thing to kind of be aware of is that you have to have an instance of this Claire scanner running for the tool to be able to submit the containers to Claire and get the report. You'll see here that there's some Docker commands which you can use on a machine to bring up Claire. And this is actually using the work of someone who has created and maintains Docker images where the vulnerability database is preceded. So usually if you go and look at the Claire repository and you try and start up the scanner, they will have to download all of the CVE information for the scan before you can actually get anything useful out of it. These Docker images kind of set you up with a database already populated from a certain date, and then a container which is set up with this Claire service in order to talk to that preceded database, so we can actually do a scan sensibly. I'm going to switch a second here and bring up my terminal. So this is my machine where I've gone through and I've got the code for this, and I've run the Python install. And also I've already started those Docker containers with the actual Claire scanner itself and the preceded database, which is in this case was 14th of June. This one was built. And then I have my Claire Singularity command. I can ask for help here, and it'll show me the kind of flags and things I can set. I don't really have to use any flags if I'm following the instructions, and I've just Docker run that Claire instance. Just like the README says, I can just go ahead and scan a container. But if I want to see what it's doing behind the scenes, I can use verbose. And the way Claire works, it kind of pulls in layers of containers. So this tool has to serve up the container for Claire to pull from it. So that's why we have the ability to set a bind IP and a bind port if it doesn't work with the default. Okay, so let's go and run a scan a minute. I can say Claire Singularity, and I'll use verbose a second here just to show you what's going on in more detail. We'll say bind port 8081. By default, it'll use 8080. And this is just to point out that if you can't use 8080, you can change the number here. And we'll ask it to scan an Ubuntu 2004 CIF, which is recent and should be all up to date. Behind the scenes, what's actually going on is it's calling out to Singularity, and it's taking the Singularity image file, and it's just dumping it into a directory as a sandbox, and then putting it into a tar format so it looks like a Docker layer to the Claire scanner. And then the Claire scanner is going to go ahead and retrieve that from the tool. The tool is actually going to serve it up at a kind of temporary location. Scanner retrieves the tool, and then the tool will ask the scanner for the results. So this is a completely up-to-date Ubuntu 2004 image. So you might be a bit surprised that it says that it found 18 vulnerabilities in 8 features or packages. But if we go down through and start looking at these, you'll actually see that they're severity low, negligible, and so on. And if you kind of follow through the links and you want to look at these, most of them are things that have a CVE filed against them, but they're marked as won't fix. And this is sort of fairly common, and it shows why you can't just run a scan against a container and look for 0 vulnerabilities, because even with a completely up-to-date image, that's not going to happen. You've got to take the results and you've got to interpret them in some way to decide whether it's significant or not, if there's something which needs fixing. Yeah, Dave, you raised your hand.
Yeah, so in particular on Singularity, where we only run things, we run the containers unprivileged. You know, I would think that a lot more vulnerabilities would be relevant to Docker containers than they would be to Singularity containers. In fact, I've made the arguments in our security, in the security teams, well, don't we need to scan those containers for vulnerabilities that make sure they get up to date? What can somebody do as an unprivileged user?
Yeah, so I mean, you're right. There are a large class of vulnerabilities which don't sort of really apply. So privilege escalation ones through applications. As long as it's not a bug in the kernel, well, that will be blocked when you're running your container as a user with Singularity. The type of thing that is still very relevant is when you have applications and you're running an application in a container, and the application itself is meant to have some kind of authorization or authentication, and it doesn't work. So people do run web services in containers, and if the web service expects to allow interaction from multiple users, and really the authorization stuff has a security issue, so other people can kind of get into data which shouldn't be publicly exposed on a network port, things like that. Those are the types of issues which are still highly relevant.
So if you're not running any web services, there's hardly anything.
I
haven't been able to think of a good example.
The...
I haven't been able to think of a good example of what it could be. Hardly, if it's just an application client and no service.
Yeah, I think it depends on the information security posture where you are. Some places would consider sort of, if you run a command line tool and there's a way of feeding the command line tool some file and it does something unexpected, like potentially allows you to access files outside of the scope of where the data should be. That's something that some people would consider a security issue. Now, if you're a user and you're just accessing user files, you could do that as a user anyway on the system, but it may still be considered a security issue with the application. And different security kind of regimes have different views on this. It's a bit of a difficult one. I can actually run a scan here. I'm going to run a scan against a bit of an older image. So I pulled down a CentOS 7.8 image, which is a bit out of date. You can see the tool's not perfect. It's going to give some warnings here because there are some unreadable files in the container when I'm running as my normal user, but this doesn't affect things. Here we end up with a much longer list, right? And there's a bunch of stuff in here which shows it's medium or high, and we might find some critical ones. But here we can see that there's an issue with some bind packages, and you do have still things like DNS resolution stuff going on in a container. So it is possible that a container could succumb to some kind of DNS poisoning or something like that if there's a vulnerability in those libraries. And similarly in basic libraries like glib or glibc and so on, there are potentially things which could happen. Maybe they're kind of not direct security issues. Maybe you'd think of them as more indirect things. They require some external action as well, like poisoning DNS or whatever. But these are types of problems which are considered by InfoSec groups.
Yeah, I have sort of a related question. So I too got really excited about Claire and security scanning a couple of years ago. And I remember I scanned my first container and then this stream of CVEs came down the screen. And when I started to look into them, I realized that I didn't have any good sense for which ones were actually, impactful, which ones were relevant to my use case, as you just talked about. Depending if you're running an unprivileged container, not all of them are going to be relevant. And then I started to look into like, okay, how do I go down this list and like fix them? And I realized that a lot of them were sort of just in like the core OS, and I had just sort of I had done a poor choice of choosing my base image. And if I changed from like, I don't know, Debian to Alpine, I got rid of a lot of them off the bat. So as kind of community members, how do we even begin to think about like, how do we begin to filter this space? How do we begin to say, okay, this is a CVE that I should be concerned about. This is something that I can fix, versus just being like, okay, let's just like try to figure out what base containers might be safest for us to use. And then like, this is only CVEs, right? So what about the issue, for example, recently where there's like all these malicious packages on PyPy that are stealing, stuff on your computer and that sort of thing. So I guess my higher level question is like, we have these tools, we get output from these tools, but how do we act intelligently and respond to this output?
I mean, this is an area really where there are numerous companies trying to answer those questions now, with quite complex and often expensive products and suites for this type of stuff. And the way the information is kind of spread around, I would kind of say that for the vulnerability kind of filtering, there isn't really a way that we can really do this. The vulnerability lists are like a fire hose of information, and the kind of details you need to know whether something applies when a container is being run unprivileged in Singularity are kind of spread around. There's no one really kind of collecting that in a way where you could easily use that information and filter a list. It's a huge topic. And then yes, the poisoning of package repositories and things outside of the OS packages, like in a Python package index, it kind of brings up another level. It's an interesting topic to kind of think about in a different venue. I think it's something which could take a very long time to kind of discuss.
I mean, especially in the context of Singularity, that was what we're talking about. And my perspective is, system administrators, if you look at it from the perspective of a system administrator, they worry about patches and CVs all the time because they don't want the users to be able to escalate, right, and to attack the system. We don't have any of that problem. I can't imagine any case of a container bug that which run inside Singularity that would then allow them to get out of Singularity and harm the system. So if that's the main, that's the main thing that we worry about, and I think we've argued that this is why we want to use Singularities as a container system rather than Docker, because Docker does have ways of getting out.
So yeah, that's kind of the base level of security, but the other bit is the application in the container. If I'm running in my container a PHP application and it provides access to some scientific data, and that data is somewhere on my HPC system which is bound into the container, and there's a web interface and different people can access different bits of data. Okay, that's a container which is running, accessed by multiple people. Now, if there's a bug in PHP's authorization functionality, so that people can impersonate someone else when they connect to this server, which is running in the container, well, that is definitely a security issue, which is in the container, because the version of PHP is insecure. Its authorization functions don't work properly. And that's nothing about sort of escaping a container, but the application in the container is insecure. So those things do arise. It's kind of a bit less common when Singularity has been used to kind of run command line apps in batch. It's more common when you start looking at instances or serving web interfaces or things like that. Okay, I think we're going to move on from the demo bit, and we'll go back to the agenda. So next time we're going to have a non-Sylabs guest joining us, and they'll be presenting their open source alternative to the Sylabs library, which you can host locally. So watch out to the mailing list and the Slack for more details of that for next month. Okay, next item. I can give a brief update of development work on Singularity CE. So if we look at the changelog, we did issue a 3.8.1 on the 20th of July. This was really quite a very small release. There were a couple of things fixed so that people who need to have a literal $sign in an environment variable in the container can do that. And when you have absolute symlinks, that they are handled properly when you copy between multi-stage builds. There was also a very minor thing, removing an out-of-date reference in an error message. So 3.8.1 was a fairly small release. What we've been working on since then is kind of in this changes since last release. If you follow this, this will show what's been merged for the next version of Singularity 3.9. We have fixed a really long-standing regression, which is something which worked in Singularity 2.x and hasn't worked in 3 at all, where labels from Docker and OCI images weren't coming into a Singularity image. So that's now working. Also, the file section, when you kind of copy things in 2.x, that was that code was written in shell. So it used the kind of shell rules for matching files and things. In 3.x, it's written in Go, and there are some problems with substitutions and things happening incorrectly in those blocks. So we've actually decided to switch to how Docker does this, which is to use the Go globbing rules to match patterns when you've got a star or a question mark wildcard in a file section to copy files into a container. Writable tempfs can now be used with Singularity build. And the reasoning for this is so that when you run the test section of the build, you can have a writable tempfs in case there's software that needs to create some temporary files during the test block of the build. You could previously do Singularity test with writable tempfs, but the test block during the build couldn't run with it. So that makes it more consistent. And we've got some bug fixes around file copying again. We pulled in the bug fix from the HPCNG repository that Dave worked up for some mount info lines. And there's been a fix for the bootstrap on different architectures where Debian's architecture name doesn't match the Go name. So if you're working on a power system, Debian calls it PPC64EL, but most other places call it PPC64LE, and that was causing an issue. Any questions about those changes? Okay. What we're continuing to do now is work through the items on the 3.9 milestone. You'll see if you watch this that we've been picking off fairly small things generally, and we're going to be moving on in this month to some big ticket items like supporting C groups v2, finalizing our use of the NVIDIA container runtime tools to set up NVIDIA GPUs in the container, and a kind of Docker-like mode, which should make it easier to run Docker containers, which expect more isolation rather than having to know all the combinations of sort of contain all, no mount, and things which kind of mimic Docker a bit more closely. So there's a bunch of things in here. What I would say is, if you have any kind of smaller wish list items for Singularity 3.9, then please try and get them in as issues as soon as you can, so we can sort of be confident that we're going to get everything done by the release date, which is down for the 23rd of November. It seems like a long way, but it comes quite quickly. The other thing I could highlight is that there's been a bit of discussion on issues with someone called Michael Young and Vanessa around using the ORAS functionality in remotes. I've been doing a bit of work over the past couple of days looking at that and trying to fix some sharp edges there. That's ongoing and will be merged in the next couple of days. Any questions on the general development? Okay, I'll carry on then. I'm talking a lot this this month, because Adam is on vacation. So Adam was going to give a bit of an update on his work on SIF, the Singularity image format, the Go module for that. But he's left some notes. So essentially, what he's doing, he's working on a version 2 API for SIF. So SIF is kind of at the core of what makes Singularity different from other container runtimes, that single image format and what you're able to put in these SIF images. And therefore, it really does make sense to put some time in making this nice and tidy, looking at bits of the code which are kind of awkward to use, and really improving that. So Adam's been doing a lot of work there. He has put out some alpha releases of the SIF module, and the API he's kind of settled on now is unlikely to change. There is a significant change between SIF v1 and SIF v2, in that an unmaintained dependency that we used for dealing with UUIDs has had to be replaced with a different package to provide the same functionality. And that is a breaking change, because any program like Singularity using SIF then has to also change what it's doing. And that was kind of the initial driver for this work, and that's been kind of put in place now. The changes to SIF are going to be rolled into Singularity for the 3.9 release, but we will continue any bug fixes and security updates on the V1 version of SIF. As a reminder, Sylabs provides long-term support commercially, so we have kind of a vested interest in doing that security and bug fix work on SIF v1 even after 3.9. So that will definitely continue.
I have a quick question.
Yeah.
So when you say SIF version 1, version 2, I see in this little snippet here, it's talking about the API. Are you talking about changes to the underlying design of SIF, or changes to like SIF tool in the way that that's interacted with, or both?
So this is not changes to the incompatible changes to the file format at all. This is mainly the Go language API. So if you're a programmer and you're going to call into the SIF package to do operations on SIF, like create a SIF or add another partition or things like that, it's changes to that API. The concepts and things are still the same. The format still has the same header style and descriptors and things. There have been a couple of deprecations of fields associated with things in the CIF, where, for example, it turns out it doesn't make sense to track a UID and a GID associated with a descriptor in a CIF because, well, really, what does that mean when you have a container and you have a file system or a config file? Does the UID and GID of the person who produced that on another host really matter? The thought there is no, so those have been deprecated. So V2 isn't sort of a completely different on-disk format. V2 is about the Go API that's being exposed for software like Singularity or anything else to use.
Gotcha. So this is kind of a cool idea. Do you envision that developers will do other things with CIF that is like outside of containers?
Yeah, so we are, and Adam is particularly thinking about what other cool stuff we could do with CIF. And I know Vanessa, he kind of raised some stuff in the containers working group, right, about what you might be able to do between kind of CIF and OCI, where those could meet in the middle a bit more, right? So part of this work is also to have things tidier, to think about that and allow thought about that. Okay, that's the CIF stuff. Now I guess we can ask whether there are any other questions, and if anyone else wants to speak other than me, please do just let us know what you want to talk about.
I have a silly question. So is it going to be kind of like Python where because we're at 3.9, we would be expecting 4.0 next, but there's going to be like a 3.10? Like what is like the, I don't know, the 1 to 2 year vision for releases of Singularity?
So for Singularity CE, I think it looks like we will either go from 3.9 to 4.0, or we will have another 3.10 and go to 4.0, right? So that would make it either about 9 months out or another 6 months after that to have a 4.0. And the 4.0, when we kind of get there, we have plans to make quite a few sort of breaking changes to things. So we want to make, for example, the versioning of Singularity CE really work with the Go ecosystem and semantic versioning, so that it makes sense for people who might want to import bits of code from Singularity to use in other things, that they can do that. We also have in our roadmap things which will break the CLI. Okay, so we have been seeing quite a lot that the remote command is really quite confusing, and we really want to try and sort that out, but we're constrained what we can do there because we don't want to change the CLI hugely in a 3.x release. We'll do that in a 4.0, and it's not clear yet whether there will be a 3.10 before a 4.0, but that's something that we should be kind of getting to over the next few months as we get closer to 3.9 and see how our roadmap items look, whether there's substantial stuff which we should and can do in another 3.x release, or whether we need to have some breaking changes and go to a 4.x at that point.
Has there been any kind of discussion about kind of supporting tools or something like that to go alongside Singularity to for example, to help to use, I guess, sort of like plugins that could go along software in HPC. So something to make it easier to assess like compatibility with the host MPI. Has there been any discussion of either tools or standards, or thinking about like labels or metadata that could kind of get us closer to that?
We haven't done a lot of thought there, to be honest. I think one of the challenges is that whenever in the past we've spoken to different people about what type of metadata they want to keep around compatibility of containers, you get different answers. So I kind of personally take the viewpoint that we're developing a runtime, and it would be great if things like the containers working group and so on reached some kind of consensus on what type of metadata should be tracked and is important, and then we can look at that set and think about it. The purely kind of metadata based stuff and then verifying compatibility, I really think needs to go down that route. With regard to MPI more generally, we have an item to look at making it a bit easier to run containers with MPI to kind of look at the host stack and try and handle some binds or whatever automatically, but that's not exactly the same thing.
Cool, thanks.
I wonder if Vanessa can say a little bit about her Singularity Hub on GitHub. I saw some tweets from you and I didn't really understand them.
Oh, about Horus, or?
If Dave agrees that that's a good thing to talk about. I don't know which chorus. I don't recognize that, but you were talking about. I don't know. Maybe that's what it is.
Yeah, I'm happy to talk about that if Dave would like me to.
Sure. Hopefully this meeting can be more than me talking most of the time. So go ahead.
I've been talking too much too, so we're both in the same boat. So, so basically, what I discovered, and actually it wasn't me, it was I was working with someone on a recipe that would build Singularity containers in a GitHub workflow, and then it didn't really have a good suggested place to deploy. So, for example, I made a client many years ago, also called Singularity Registry client, that would push to like a Google Cloud Storage or AWS. So that was like the only option. And so the person I was working with said, "Hey, what about this ORAS endpoint? Singularity has that, and basically it's pushing something as an artifact to an OCI registry." And so we kind of squinted our eyes a little bit and we looked at GitHub packages. So GitHub has this thing called packages, which is pretty flexible. It obviously there's backing for OCI containers, so OCI sort of objects, but also Docker containers. There's also like NPM. I think PyPy is coming soon. And we just realized, like, wait a minute, maybe this already works. Maybe we can just take this container and then, Singularity remote login to first authenticate and then push just with the ORAS, URI, or that little prefix that you put before the name. And lo and behold, it worked, which basically means, so what that tweet was sharing is that it is now easy to create a workflow on GitHub where you have some number of Singularity recipes in your repository. The workflow will build the recipes on a pull request. You can also test them in there, do whatever extra things you need to do to make sure things work. And then on a merge to your main branch, or maybe when you release, it will do that same build, but then push to the GitHub package registry. And then you can also pull down natively with Singularity. So this is like a huge deal in my mind, because this is really the first solution that's been out there. Like Singularity Hub that I used to host has gone away. I changed jobs and I couldn't bring it with me. But now there is an option for people to build, to create automated pipelines to build and deploy containers and pull them easily without sort of like limits on the size or the quantity. So I was just like joyous. I discovered this late at night and I just totally lost my mind. But that's basically it. GitHub packages, you can push to them from Singularity with ORAS.
So inside your a CI, like a GitHub action, you're pushing the image you built to where? Where does it go?
It goes to GitHub packages, which offers actually different kinds of packages, but one of them is, you can think of, so you can push Docker images. That's one of the options, but another one is that they actually implemented like the OCI spec to support an ORAS. So ORAS is, I think it means OCI Registry as storage. If you go to, I think, oras.land, there's a little website that describes it, but it's sort of this common language to interact with an OCI distribution spec, so an OCI registry. And that means that anything that implements that, so Singularity does implement the ability to push to an ORAS endpoint, will be able to accept it. So that's how we can push a CIF binary, just that is as it is, no tricks here, and then pull it down just as it is.
Then you can just use you can, as long as you authenticate presumably to push, but then you use a short URL, like something like a GitHub URL. But this is,
oh yeah, so I should make that just explicitly clear. So akin to how Docker Hub, you can pull down Ubuntu or whatever, and that's sort of one of their core images. Different container registries have different like prefixes. So GitHub Container Registry is ghcr.io. And then, for example, if my repository is vsock/pancakes, then if I push a container from there, I can push from vsock pancakes with a tag like latest or a tag like the commit shop, really whatever I like. And then the cool part is then when you go to the repository, it shows that the container is associated, or the quote package, which is a container, is associated with that. The one kind of buggy thing is that so the container does have its own like little page in GitHub packages, and the first thing it shows you is like, oh, here's how to Docker pull this container. And because pushing to OCI with Singularity, I think it creates an empty config. It's sort of like a hack, but it works. If you really do try to run that command with Docker, it's not going to work. So that's the one kind of buggy thing that could be confusing. But as long as you put enough documentation in your README, which is also rendered alongside the container, you should be okay for the time being. And hopefully they'll fix that in the future.
So the pushing the null config is actually a kind of the reason that push a null config is because if you push a sort of valid config for it, Docker, when you pull, it won't just kind of die straight away. It will actually retrieve the binaries and then try and do something with it and die much later on after you pulled a load of stuff. So there's not a kind of simple way around that at the moment. It's
yeah,
it's
probably better implemented that it fails quickly as opposed to trying to do something that it can't.
Yeah, that's the reason why the ORAS documentation tells you or kind of shows pushing a null config by default.
So you probably need to be very careful with the amount of these that you do, because it's going to, I mean, it's going to be an awful lot of bandwidth and space and things like that.
Oh, so I'm not, so, I mean, obviously like anytime, GitHub, which is run by Microsoft, be like, oh, we're going to put limits on this. And, maybe that'll happen someday. But I can tell you that I help run a kind of GitHub packages-based container registry named Optimus. And we are building all the time and pushing all the time. And I really don't think people need to be concerned about that. And especially researchers who might have a couple of containers per GitHub repository that they build at most, I don't know, like what's going to be a frequent build, someone merging to their branch every, in Singularity Hub, we used to have people that would build on every commit. So yeah, they build many times per day. But in GitHub's, in GitHub land, that handles, I don't know how many they handle, but I can imagine they handle millions and millions a day. So I don't think people, at least now, until there's evidence that they should be, I don't think people should be concerned about that.
So it's basically free for public images. So if you're making it public, you don't have to worry. If you want to keep things private, then there are limits, and they're quite tight on the free account.
Oh, interesting. I didn't know that.
Yeah.
It's funny, when I first started using it, my images were private by default, and it took me a while to figure that out and then make them public. I guess the Yeah, that's a good point. Probably if you're like creating some secret container sauce and you don't want to share it, and you're some company or something, you'd want private. But I think for the most part, for the communities that I'm thinking of, so scientists and researchers that already work very openly, I don't think they would have concern with public.
And one more kind of comment from me. I'm aware of people doing kind of similar things with actually GitLab. So GitLab has a container registry, and you can push into there. And we know there are some people doing Singularity builds within a GitLab CI run and pushing containers using the ORS into the GitLab container registry too.
Yeah, that's spot on. I had a registry, or sorry, I had a recipe for that a few years ago too. And you could also just, GitLab has better support for just like storing an arbitrary artifact too. But I think, yeah, I think that now you can just push to a registry. I don't know why, I've always liked GitHub more than GitLab. Like I've used GitLab a little bit. Like remember when Microsoft took over, I was one of those people that like jumped ship and I was like, I'm gonna go to GitLab, but I haven't really used it that much. So I probably need to get back and try it again.
Well, when I think about bandwidth, I think more about the reading than the pushing. So if you have an HPC system and you want to download a separate one to every compute node, and you have hundreds of compute nodes, you got to be careful on how you do that.
Oh yeah, and that's something, for example, we're talking about in the containers working group, just how there should be a better kind of, I guess, orchestration for actually, allowing the user to pull one container and then distributing it to those nodes. Because you're totally right, and actually Singularity Hub got in trouble because someone did exactly that. They had a really big container and they were pulling it to thousands of nodes and pulling all at the same time. Yeah, that was disaster, but I think that's a different. I don't think GitHub per se is super worried about that. I would imagine Microsoft has infinite resources, but you're totally right that that's something that we should be we're very concerned about.
Cool. That's an interesting thing to hear a bit about, and I don't know whether there's something there which you might want to demo in future, Vanessa, or someone else might.
I can share the repository. It's pretty well documented, but if anyone has any questions, just please open an issue. I did it in like one night and I typed it up. So like someone found a spelling mistake today, which is embarrassing, but tends to happen when you're like programming like a mad person at like 11 o'clock at night.
Cool. Any other topics? Anything that anyone wants to raise?
Yeah, thanks, Dave. Just following on from that conversation, we've actually implemented a GitLab workflow that does push Singularity images around. We've actually implemented a GitLab instance locally to do that, and that avoids some of those issues that we were just talking about pulling from the cloud and all the traffic there. But we've touched on exactly those same issues around how do we push a Singularity container or CIF file to the GitLab instance. And so we've used the packages component. And so we're using a generic binary format to be able to push our CIF files into there. And we're just on the journey now where we're trying to just convert that over to using the container registry in GitLab locally as well. So it's very relevant to our workflow, and it's a scientific-based workflow with the Queensland government. So we're very interested in this whole space as well. So interested to get in touch with Vanessa and yourself around all of these pieces moving forward and have a really solid workflow for GitLab in particular. So that's really, yeah, where we've got interest at our end. Thanks.
Great. Anything else before we call time? Okay, well, as usual, this will go up on YouTube, and I'll share the link, and we're around in the Slack and on the Google group list if anyone wants to ask any questions or anything. Thanks for coming, and we look forward to seeing you next month if you're able to make it. It is the different time slot. We're trying out the kind of alternate time slots to pick up people from different time zones, and as I mentioned, there'll be a demo of a library alternative. Thanks for coming.
Thanks, DT. See ya.
Thanks, Dave. And
Thanks.
Dave.
Thanks, Dave.
I know.